Welcome to A+ Economics, your guide to an A+. In this video, we'll be discussing the measure of shape, the empirical rule, and Chebyshev's theorem. Let's get started.
Before we delve into the specific theorems, let's first talk about the measure of shape. In statistics, we often encounter different types of data distributions. Some data sets have a bell-shaped curve, others might be skewed to the left or right, and some may even have multiple peaks. The measure of shape helps us quantify and describe these characteristics. Now, let's move on to the empirical rule, also known as the 68-95-99.7 rule. This rule is applicable to data sets that follow a bell-shaped or normal distribution. According to the empirical rule, approximately 68% of the data falls within one standard deviation of the mean. Roughly 95% of the data falls within two standard deviations of the mean. Nearly 99.7% of the data falls within three standard deviations of the mean. Moving on to Chebyshev's theorem, which is more general than the empirical rule. This theorem applies to all types of data distributions, regardless of their shape. Chebyshev's theorem states that, at least, 1 minus 1 divided by k squared, of the data falls within k standard deviations of the mean, where k is any positive constant greater than 1. Unlike the empirical rule, Chebyshev's theorem doesn't provide specific percentages like 68%, 95%, or 99.7%. Instead, it gives us a minimum proportion of data within a certain range from the mean. And there you have it. We've covered the measure of shape, the empirical rule, and Chebyshev's theorem. Understanding these concepts will aid you in analyzing and interpreting data more effectively, whether you're working on a research project, business analysis, or any other data-related endeavor.
If you enjoyed this video, give it a thumbs up and subscribe to our channel for more exciting content on statistics, economics, and other intriguing topics. Don't forget to hit the notification bell so you never miss an update.